Presentation on HPLC. High-performance liquid chromatography, also known as high-pressure liquid chromatography, is a separation technique using the principles of chromatography and is a derivative of column chromatography. Chromatography is a separation technique that relies on the unique polarities of each compound, therefore allowing them to be separated out of the analyte. In chromatography, the solvent moving through the column is called the mobile phase, which is used to carry the analyte over the stationary phase. This can either be polar or nonpolar. The substance left in the column, which is also the substance left in the column. The eluent is the fluid entering the column. The eluate is the fluid exiting the column. The eluation is the process of washing out a compound through the column using a solvent. A small amount of the analyte is pumped into the column packed with the stationary phase with the solvent. The solvent then flows through the stationary phase under high pressure as indicated by the name HPLC. The sample is carried by a moving carrier gas through a stream of helium or nitrogen. The different compounds in an analyte will travel at different speeds through the stationary phase due to the varying affinities to the stationary and mobile phases, which results in the separation of the compounds. The compounds that adhere most strongly to the stationary phase or most weakly to the mobile phase will travel slower than those which have a weaker adhesion, while the opposite is also true. The strength of adhesion is dictated by a compound's absorption, how well a compound sticks to the stationary phase, and solubility, how well a compound dissolves in the mobile phase. These change dependent on the stationary and mobile phases and are caused by a molecule's polarity. In HPLC, the stationary phase is a solid, using silica or alumina, and the mobile phase is a liquid. The competition between the stationary and mobile phases pulling at the components is what drives the separation. HPLC works with very small quantities and contains a very sensitive detector. The main component of an HPLC system includes the solvent reservoirs, which holds the mobile phase. There is usually a minimum of 2 and is fitted with a gas diffuser. A high-pressure pump, which is used to generate a specific flow of mobile gas. A column, which is packed with the stationary phase, and an injector system, either manual or automated depending on the system, and the detector. The detector is used to see the separated compounds as they eluate out of the system. The detector uses ultraviolet absorption to detect the particles since many organic compounds absorb various wavelengths of UV light. So the detector can detect how much light is absorbed. The amount of particle that is present results in the amount of light that is absorbed. A chromatogram is then generated. However, this type of graph does not depict the concentrations of the compounds. Rather, the peaks generated as the separated compounds pass through the detector. On the x-axis, it measures the time, and on the y-axis, it measures the concentration in terms of detector response. The response is depicted as a peak whose height is ideally proportional to the concentration of the compound, but more accurately, the area under the peak is the concentration of the compound. Each separate peak is a separate particle present in the mixture. The retention time of particle is characteristic to that component under those conditions, and is measured from the time the sample is injected, so right here, to the time of the maximum of the peak is reached. These retention times can be used to identify the compound. I compared the HPLC to the finishing of a race. Initially, all the participants of the race are lined up similar to the analyte in the HPLC. Once the pressure is increased or the race is started, the different molecules are separated based on their specific properties, similar to how in a race the athletes are separated based on their physical abilities. The physical abilities of the runners will result in which runner finishes first and which runner will finish last, similar to the specific polarity and molecular weights of the molecules, which determine which particles will be separated first. Increasingly throughout the time of the race, the people will become further and further spread out. as the more athletic individuals will be farther along with the slower and less athletically inclined individuals behind. This correlates to the HPLC, where as the time increases, the molecules will spread out based on their physical and chemical properties. Lastly, when the judges or those who record the results of the race, they record who finishes and the times they finished. This is similar to the detector, which graphs the concentration of the compounds passing through on a chromatogram graph. There are multiple different applications for HPLC. HPLC has various applications in both industrial and scientific settings, including pharmaceutical, environmental, forensics, and chemicals. In laboratories, HPLC can be used to separate an analyte, a mixture containing two or more different organic compounds, into its individual components so that it can be analyzed. HPLC relies on pressure rather than gravity separation, making the separation process more precise, able to read the concentration of parts per trillion, and faster compared to other forms of chromatography. Additionally, because of its precision, it does not require a large amount of the analyte and solvent. HPLC can also be used to obtain a certain compound from the solution, or to purify a solution by removing a specific compound. HPLC produces a chromatograph, a graph that depicts the real-time peaks of the compounds as they pass through the detector, which can also be used to analyze the solution. Thank you.